In this tutorial, we will show how we can use the various CDS services, SIMBAD, VizieR and Aladin, to get information on a sample of astronomical objects, in this case low surface brightness galaxies. We will start by a query by identifier in the SIMBAD web page. On this form, we can simply enter the identifier, the name of an astronomical object, and we will look for a galaxy named GMP2552. When we press enter, we will get the SIMBAD result page, which tells us the main object type. We also see that it's a low surface brightness galaxy. There are coordinates, a few magnitudes, and a preview image from the DSS color survey. It's very faint, so we see it a little better in the SDSS survey, but we will find other surveys where the galaxy is more visible. For this object, we have 3 different identifiers, as is often the case for astronomical objects, and we have 8 bibliographic references. If we look at the various references, we see that sometimes we have a number of objects detected in the paper, and we can also have links to tables. In this case, it's the VizieR service which is hosting tables associated to this paper. We can open the link in a new tab, and we will land on the VizieR query page for this catalog. It's a very small sample. We only have 68 rows in this table, so we can quickly ask all the data and visualize it in the browser. But it's more convenient to visualize this table in a tool like Aladin Desktop. We have Aladin Desktop started here in the background. By default, you will get an image which is from the DSS survey, the Digitized Sky survey. It's a color survey made from photographic plates, and it covers the full sky. Coming back to the web page, we can ask to broadcast data displayed in VizieR to Aladin Desktop. This is done with this radio antenna here at the top. If we click the icon, we need to grant permission to the browser to communicate with Aladin Desktop. And once this is done, we can click the broadcast button here to send a copy of the data displayed in the browser to Aladin Desktop. And as we can see, there are no symbols here corresponding to the sources from the catalog. And we can view the corresponding measurement at the bottom of the table. If we click on individual lines, we can then zoom in and try to visualize the object in the DSS. They are all low brightness galaxies, so it's better to look for a different survey in order to have a chance to view this. So you can use the collection tree search here to look for example, Pan-STARRS survey. We will load the color version of the Pan-STARRS survey. We will also look for DAISY, the DAISY Legacy Survey color version. And as you can see, we see much better these low surface brightness objects in surveys like DAISY. We will also load an HST survey made from measurements in the V band. If I look for HST here, we will take the HST wide V progressive survey. For this one, I will also display the spatial coverage of the survey. So when we load this survey, we see that HST observations are very small. They have very small field of view. And if we zoom out to view the full sky, we see that they are scattered all over the sky. Now what we will try to do is to get also the spatial coverage of the Pan-STARRS and DESI surveys. We can look back Pan-STARRS survey here and load the associated STMOC. As you can see, it covers the 2/3 of the sky, and the DESI survey has a coverage which is also quite significant. So having these 3 coverage description, we will try to compute the intersection of the 3 MOCs. This is done by selecting the MOCs here in the Aladin stack and going to the coverage menu, compute a logical operation for the 3 MOCs, which is by default the intersection. We want the intersection in space, so we remove the time constraint and we create the intersection. This is very fast, it's already done. And now the pink region in this new plane corresponds to regions of the sky which have been observed by Pan-STARRS, DESI and HST in the V-band. So if we take our catalog of low surface brightness galaxies, we can try to see if they have been observed in these regions or not, but it's a bit of a random chance. So what we will do next is take another catalog, which we will query directly from the Aladin collection menu here. It's called the smudge survey. So I take it from the tree. We will ask for the whole data, which is 7,070 sources. If we download it, we view this catalog, which covers a significant fraction of the sky. But now we can ask the question, which of these sources fall inside the pink MOC, which correspond to observation by Pan-STARRS, DESI and HST. This is a quite complex question, but it's very easy to solve with the MOCs. We can just either take the full catalog that we downloaded here and filter a table by MOC. This will bring a menu where we can use the intersection MOC as a constraint for the catalog, which is APGS 267. And we can ask for sources from this catalog which fall inside the MOC. When we do that, we will find 121 sources. We can also do it directly. If we select the MOC in the plane here, when we query the catalog here, we can ask for sources which fall inside the MOC. And when we do that, we will get a plane which contains the same number of sources. To have confirmation that this worked, we can now select 121 sources which have been filtered out of the 7,070 sources and try to zoom in, but we will split the view into 4 panels, have DESI on one side, Pan-STARRS here, HST there, and just the DSS as a control here. We can use the match button to synchronize the 4 panels. We hide the MOC, and now we can simply, for example, sort by magnitude, and go through our galaxies, and we see that they are indeed visible in the different surveys. Sometimes they fall just outside because the MOC is computed a bit larger than the actual coverage. So it's something that you have to take into account, but it greatly simplifies the search for common observation across different surveys. We have done this job here manually, but you can also do things programmatically with the CDS tools. There are first a number of image surveys from which you can select. We've got over 1,200 image surveys currently. If you want to generate thumbnails from different surveys, you can use the Heaps to Fits service, which is able to compute cutouts from Heaps surveys. And if you want to write a Python script that will automate this process, you can use widgets like the IVOA Aladin, which you find in the CDS GitHub site. And there are also a number of tutorials that you can follow in order to learn how to use the CDS services with Python. Thank you for listening, and see you soon.